why its benefits and why it is in instruction. In order to know what is addressing mode, we have to know what is instruction. So here instruction is basically a binary code, specifies a basic operation. So in instruction, computer instructions are a set of machine language instructions that are a particular processor understands and executes. Computer performs tasks on the basis of instructions provided. That is, the arithmetic problems which are used in a day-to-day life cannot be known by computers because it's in human language. So in order to know the language, the computer has specific instructions. In instructions, there are basically three known fields. The compounds that are opcode, that is operation code. In operation code defines the operation or the arithmetic problem that is performed in the instruction, and then the address field, which contains the location of operand, or that is the register or a memory location, and then a mode field which specifies how the operand will be located. So the given diagram is the basic information instruction format that has mode, opcode, and the operand or the address of the operand. So the basic computer has three instruction code format. The three instruction code formats are memory reference instruction, register reference instruction, and input output instruction. So memory reference instruction is a 12-bit of memory is used to specify an address, and 1 bit to specify the address mode, and another is used to specify the opcode. So the register reference has reference number, and the opcode has 111 with 0 at the left side. In the input output instruction, just like the register, it does not need any reference to the memory, and then it is recognized by 111 with 1 at the left side. So yeah, and then the opcode and the operand follows the stores program concept, and the instruction and register follows the instruction set architecture. So in instruction code format, so instruction code format has the three types of thing, as I already said. So it's the memory reference instruction, register reference instructions, and input code output instruction. So here the memory reference instruction is the 12-bit of memory, and it is used to specify an address, and 1 bit to specify the address mode. The address mode would be having 1, and the rest will be having the address mode. Here in the register operation, it is recognized with 111, and at the left side, leftmost side will be having a 0, and input output instruction will be having 111 with the leftmost side 1 to identify the register and input operation. So operation and operand. What are operations and operand? Here the computer performs the arithmetic through the operation. So for example, if we take add A, B, and C. So it adds B and C and stores the sum in A. Here the A, B, C are the operands, and the add is the operation. This one can be easily written in human understood language, but in order to understand by the computer performs certain techniques where in that thing instruction comes. And then its types. So instruction has 4 types, and this instruction is classified with the help of its address. So there are 4 types: 0 address instruction, 1 address instruction, 2 address instructions, and 3 address instructions. Here the 0 address instruction is a very commonly used instruction where it has no field. such as in stock organization. It does not have any address field, but to evaluate it needs to be converted into postfix notation. For example, push or pull. So push or pop. In an stock, if we need to, if there is already a two operand, we simply need to push or pop in the stack. So it does not need any address field for that. And in one address instruction, it is implied in accumulator register for data manipulation, where in one compound is in accumulator and the other should be in the register or in the memory location. So here it is used in the CPU mostly. And the next two types are for commercial purposes. The two address instructions are mostly used in commercial computers, such as for commercial purposes. So here, unlike the first address instruction, where the two fields present, the one operand is in the accumulator and the other is in the register. Here, there's no anything like that. It can be stored in any place, but it requires more number of bits to represent the address. Here it's like the here in one address instruction, we have to store the operand in accumulator and the other in the register. But in two address instruction, we can store it in anywhere. But the only problem in is that it requires more number of data to represent the address. And next we move on to the third address instruction, where it is mostly widely used in programs where it can be a long written programs. So in this three address instructions, this has three address fields to specify a register or a memory location. So a program that is created is much easier and shorter in pre-address instruction, but the only disadvantage is that the number of bits per instruction increases. These instructions make creation of program much easier, but it does not mean it can be faster, because the instruction would be having a large number of informations, but the each operation will be performed in one cycle only. So the total number of instructions or the information that is present in the program for the instruction is to be performed in only one cycle. So it takes time. It's not faster, but it makes the program more easier. And with the knowledge of instruction, we are going to move on to a very important topic called addressing mode. Here, the addressing mode is mostly used in instructions because of its benefits. As we already saw in instructions, its purpose is used because arithmetic operations that we do in day-to-day life cannot be easily done in computers because it does not understand human level languages. So in addressing mode, here the each instruction of a computer specifies an operation such as addition or subtraction or any arithmetic operation on certain data. So the different way in which the location of an operand is specified in an instruction is called addressing mode. So let's take an instruction format that is it has two fields. One is opcode and the address. The opcode is the operation and the address may be the operand. In this address, there may be anything. It may contain a register number, address, or even bit. So that thing is considered with the help of addressing mode and its types. So In simple terms, the term addressing mode refers to the way in which the operand of an instructor are specified. It specifies the rules for interpreting or modifying the address field of the instruction before the operand is actually executed. This operation will be executed on same data which is stored in the computer register or the main memory. The way any operand is selected during the program execution is depend on the addressing mode of the instruction. So the main explanation for this is, if we take an example of adding two numbers, say 1 and 2, and get a result. Here mathematically we can write it as 1 plus 2 and we can get the instruction. Here 1 and 2 would be the so-called operand, and the plus sign or the addition will be the operator. But this can be easily understood by us. The computer cannot. So in a microprocessor, the machine needs to be told how to get the operand to perform the operation. Here, an important term for effective address is used. This effective address is used to store address of data. That is, in the instruction format, in the address, there would be an effective address. So the effective address would be having the data, but the address wouldn't be having the operand's value. Uh, this this effective address helps mainly in instructions to reduce the number of data. That is, if this addressing mode is used in instruction, it won't be having the value, but it would be having an register number. So if we go to the register number, we can fetch the value. Thus, this helps in the reduced number of bits in the instruction. So the main purpose of using addressing mode is that to give the programming versatility to the user. And the second main most important reason is that to reduce the number of bits in addressing field of instruction. So as I already said, in instruction it is used to perform many things, like it is used in commercial purposes and it is also used in a program. So the program would be having a number of steps, so the instructions, the bit would be larger. In order to reduce the instruction bit, the addressing mode comes into play. So in addressing modes, in the instruction, they would be having a specified register number or an effective address. So if we go to the effective address place or the register, there they would be having the data or the value. Thus, this would minimize the number of bit in the instruction. This is one of the main reasons why we use addressing modes. So, we have talked about what is instruction and addressing modes. But in addressing modes, there are different types. The types, it can be stored in the type why it is used. The classification is that the operand value, it can be stored anywhere. It can be in a constant, or it can be stored in a register, or it can be stored in an implicit mode. It can be stored in a base register or an index register. So this is defined by the types. Now we jump on into an important topic, its types. Here the addressing mode, as you know what is addressing mode. So the addressing mode, it specifies the rules for interrupting or modifying the address field of the instruction. So the place where the operand is located, that depends upon the addressing mode. So there are several types of addressing modes. It can be implied, immediate, registered mode, register indirect, direct addressing mode, indirect addressing mode, relative addressing mode, index addressing mode, base register addressing mode, and auto increment and or auto decrement mode. Here, uh, direct addressing and indirect addressing mode are the most important addressing mode. It's because due to its implementation of variables in direct addressing modes, and the parameters and the pointers are being used in indirect addressing mode. Due to this um, implementation, these both is important addressing mode in this topic. And relative addressing mode, index addressing mode, and base register addressing mode. These three fall under the same category called displacement addressing mode. Here, this displacement addressing mode is the basic for these three, with slightest modification in all of that. And the auto increment or auto decrement mode. This is a special case of addressing mode that is used in the instruction, which will be learning it here in the section. So the first addressing mode type is implied mode. In this implied mode, it is the basic addressing mode that we have. The definition here is very simple. That is, the instruction format will be implicitly having the operand's value. That is, the operand may be hidden or fixed, but it is present in the instruction itself. It need not go anywhere to fetch the data. If it is a register mode, it has to go to a register to fetch the data. But here, as it is present inside, they need not go anywhere to fetch the data. So, for example, increment accumulator. In this increment accumulator, uh, this is the instruction. Here the accumulator is incremented implicitly in the instruction. Here it did not go anywhere out of the instruction. It is performed inside the instruction only. The basic mainly used is in zero address instruction and in one address instruction. So from the starting of the seminar, I have said that zero address instruction is an example of stack organization. So in stack organization, in a stack, if there are two operands, it simply pushes or pops it. It need not go anywhere to fetch the data. It is present in the stack itself. And another is, as I said, in one address instruction, the example is accumulator organization. It can be incremented, decremented in the accumulator, and it is present in one instruction only. So the advantage of implied mode is that, as we said, the main advantage is that it reduces the size of the instruction. Yes, it reduces the size of the instruction, but it is limited to one word, that is 8-bit or 16-bit long. It cannot exceed more than 16-bit long data. Error would be shown if that is increased. So the only limited and the only problem here is it cannot exceed one word. And then the next simplest form of addressing mode is an immediate mode. Here, immediate mode, from the word itself, you can tell that it is present in the instruction format itself. So let's consider an instruction format. As we all know, it has two fields, the opcode and the address. So here the address will be having a data. So the data is the immediate mode that is used in the instruction. It need not go anywhere. It does not have any register number or any bit. would be having its data itself, that is a constant value. If it's in register or in a register indirect, it needs to go to the register and fetch the data. Here it does not need anything. The data value is present in instruction format itself. So the operand will be having the data. So the operand is the part of instruction and the address field is the operand. Now let us take an example for add r1, 3. The hashtag which is used near 3, that denotes the immediate mode. So that is a constant value. So that is represented with the hashtag. Here it simply adds r1 and 3 in register 1. It does not go fetch any data anywhere in the register. The 3 that is present is the constant value and it's a direct data too. So there is no commutation required or any effective address need to calculate the effective address. So the advantage of this is no need to go to any register or any memory reference to fetch the data, and because it is present in the instruction itself, and it is this is the fastest addressing mode in whole types of addressing mode, as it has a constant value. But the disadvantage is too. The main disadvantage is that loop. The constant, as it is a constant value, if you write a program declaring a value for a is equal to 3, and if you have a loop inside that to increment a, that would be an error that cannot be performed in an immediate mode, as the a is an immediate mode and the value of a, such as 3, the value is constant, it cannot be changed. So that is a drawback for immediate mode. And other drawback is that it depends upon the address field range. So if you consider mode that has mode, opcode, and the address. Here the opcode will be having 3-bit. The total is 16, say 16-bit, and here we have 3-bit as the opcode, and 1-bit will be gone to the mode. So the address will be having 12. So the range uh, of the constant value would be 0 to 2 to the power 12 minus 1. It should not exceed more than this range. That would be an error. So here in immediate mode, it has a constant value on the instruction mode. It does not need to go anywhere to the register to fetch the more value. It is present in the address itself. But the only disadvantage is that it has a limited range, and then in a program, if it contains loop for that constant value, the error occurs. And the main advantage is that it is faster. And next, we move on to another important topic called register number, register addressing mode. Here in register addressing mode, uh, the operand will be present in the register. The main thing is that in an instruction format, we would be having a register number. There won't be any constant value such as in the implied mode or a value in the implicit mode. It would be having a register number. So this register number is the effective address. Here, so the effective the register number that is present in the instruction should be so after fetching the instruction and decoding the operand value that represents the register number, we have to go to the register and obtain the data. Mm. So that is after knowing the instruction, they would be having a register number. The register number, after we know the register number, we have to go to the register, and corresponding to the register number given in the instruction, we would be having the data, and the data should be fetched and then settled in the instruction. Uh, by this way, the instruction fetch is the fastest. A very small address field is needed for shorter instruction. This advantage is that it can the number of bits is reduced in the instruction as the value is present in the register. And it is the fastest register addressing mode. Multiple register helps performance, and no memory access is needed here in the addressing mode. Uh, so, register indirect mode. So, in this register indirect mode, what is this register indirect mode? Here the same as the register direct mode. The first process is always the same. The instruction would be having a register address. The register address would be pointing to a register. So corresponding to our register number, there won't be any the operand, but itself points to the operand. That is, so in for example, in R1, memory address is present. So if we go to, so the R1 is the register address, and if we go to the register and search R1, the R1 would not be having the operand value. It itself would be pointing to the operand. So by this way, the large address space is needed. That is 2n, as it has too many directions. It would be having a larger address space. So the effective address would be the memory of register itself. It won't be the register, but memory of the register. So to denote, we would be putting R in the parenthesis. So the only difference is whether the address field refers to a memory location or a register. So if we take an example called load R1, so if will be add R1 comma R2. Here in register 1, it would be adding R1, and it would add R2. It would not add R2, it would add the memory of R2. Why memory of R2? Because it is in register indirect mode. Register indirect mode would be having register address, and in register address, if we go, it would be pointing to the operand. So the operand will be present elsewhere, not in the register. The register would be having an memory of the operand. So the same size of instruction, but it stores many value in the register. The only disadvantage in here is that the the address space is large, that is 2n. And now we jump into a most important topic called direct addressing mode. This direct addressing mode is also called absolute addressing mode. In direct addressing mode, this one is a simple form of addressing. This addressing mode makes it special and as well as an important addressing mode due to its speciality. By speciality means it allows access to variables. It may be global variable or any variable, but it gives the access to it. So the actual address here is present in the instruction only, as by immediate or as per the immediate mode, where the immediate is present in the operand itself. The same has here the direct address mode. The data would be present in the instruction itself. But in immediate mode, it will be having a constant value. But here, it gives access to the variable also. So address field contains the address of the operand. And the effective address, as I already said, effective address is the important term used in the addressing mode. So the effective address is the address field only. And then, for example, the processor will retrieve the data directly from the address specified in the instruction. So the processor is the instruction is present in the data. So the processor will directly go and fetch the data. It need not go anywhere to the register or any main memory. By its name, direct addressing mode, it is present in the addressing mode. It is similar to immediate mode, but the only difference is it gives access to variables, and plus it does not have any constant value, need not be a constant value. So for example, um, let's say add a. So a is a variable, and that is accessed in direct addressing mode. So a, so in this accumulator, the memory of a is added, so it directly goes to memory of a and stores to the accumulator. It does not need to go anywhere to the register, as it is present in the instruction mode itself. So the main advantage of this direct addressing mode is that we already know immediate mode also has the same advantage of it. It does not need any commutation, and it's directly accessed to. So the main key feature of this direct addressing mode is that it accesses variable easily. It may be global variable, it may be anything, but easy to get in execution time. So the disadvantage of this direct addressing mode is same as the immediate. The size is fixed. That and also depends upon the addressing affair. So if it has as I've already said, if the instruction format has 16-bit in total and the 12-bit is in the operand, the range would be 0 to 2 to the power of 12 minus 1. So this is the range. It is fixed and it cannot exceed it. So the advantage is that no additional calculation to work out the effective address, and it's just limited address space is the disadvantage. So just giving a gist is that in direct addressing mode, it is also called absolute addressing mode. The advantage is that it can be implemented access to variable. So it does not need any commutation, and directly accessed, and the size is fixed in direct addressing mode. So the effective address is the address field itself, and the effective address is inside the instruction only. It need not go anywhere to register to fetch it, and thus the it is more quick. And another important in the addressing mode is indirect addressing mode. Why it is important is because it allows, as I said, altering the instruction in the types. The indirect addressing mode implements pointers and passing parameters. The pointers and passing parameters are present only in indirect addressing mode and in not in any other addressing mode. So the reference to the address of a word in memory which contains a full-length address of the operand. Here, as in register indirect, it also has the same problem in it. And register indirect, we already discussed that the instruction would be having a register number. When we go to the register, we would be having an address of the operand rather than the operand itself. So the same way, in indirect addressing mode, the instruction will have address of register. So when gone to that address, it points to the operand. Thus, the same way, it has an address space. This is just similar to the register indirect mode. They both has the same feature and the same problem too. Here, the addressing mode, when gone to the register, here the register would be having an memory of the operand itself. So, the add, for example, add x, the x will be having a register number. So in that memory, it would be having the address of the operand itself. So the advantage is that for a word length of n, an address space of 2n is available. So the disadvantage is that the instruction execution requires two memory reference to fetch the operand and one to get its address and the second to its value. Even though it has like the address spaces of 2n, the instruction requires two memory reference. The one is to fetch the operand, that is the address A. The In this diagram, in address A, the address A would be having a register number. If gone to that register, we would be having the it would point to the operand. So that is, it will be having a memory of the operand. So so it access to memory is required in order to fetch the operand. And now um, we move on to another important addressing mode called displacement addressing mode. Here in displacement addressing mode, from the name itself, you would be knowing. It is basically a combination of direct addressing and indirect register addressing mode. That is, um, here the displacement addressing mode, one field will be having address of the operand and another will be having register number, and in register it contains the address of operand rather than the operand itself. As we said, it's a combination of direct addressing mode and in the register indirect addressing mode. It would be having two fields, and the one field to will be have the instruction will have two address field. So at least one of which is explicit. That means one is the address field and it indicates direct address. That is that the one field which indicates the direct address, the register, it would be present. Direct address means it would be present in the instruction itself. So one address field would be having the operand itself, and the other will indicate indirect address. That is, in indirect, they would be having the register number. So when gone to the register number, it would be having the memory of operand rather than the operand itself. So due to this many addressing field that is present in different types, the effective address is need to be calculated. And So for example, if the value contained in one addressing field is a, which is used directly. That is, it is present in addressing field. The value of A is present, and the value in other addressing field is R, which R means the register whose contents are to be added to the effective address. So from this way we are calculating the effective address. In above all the above types, in implied, immediate, register indirect, direct or indirect, we don't need to calculate any um, effective address, because in one side, in implied or an immediate, the addressing mode, the effective address is present in the instruction format itself. And in register and in register indirect, the addressing form, the effective address is the register. So we would be going to the register to get the operand. And in direct and indirect, it would be present in the instruction format itself. And in indirect, it is just like register indirect, it should go to the register. So in all these types, we no need to calculate any effective address. The effective address may be the address of the operand or the register, memory register itself. But in displacement addressing mode, we have to calculate register address. Sorry, that is effective address. So effective address, how is calculated is that A may be the addressing field which represents direct addressing mode, and then another R, the memory of R, will be representing the indirect addressing mode. So these both gives, the when added, will give a sum called the effective address. So when gone to the implied effective address place, we would be having the operand. The displacement addressing mode has three basic uh, types classification. These three are relative, base register, and indexed. Uh, these three perform more or less the same rules for displacement addressing, with slightest change in it. So we jump into displacement addressing classification. So the first one is relative address mode. Here in relative address mode, same like displacement, it would be having a direct and indirect addressing mode. And here in relative addressing mode, it makes it special because it is highly used in program controlled instruction. That is, it is highly used in lengthy programs and in main memory. So in relative addressing mode, how the effective address is calculated is that the content of program counter is added to the address part of instruction to obtain the effective address. That is, the content of program control is the PC. The PC is added to the address part, that is the direct part, the direct addressing modes part. The content of the program control will be the indirect, and the address part will be direct. So when combined, we would be getting the effective address. So the next instruction address is added to the address field to produce the effective address. Um, in displacement, we tell a word called R, the register number, or the indirect form. So here the program control plays the indirect addressing mode format, and the A will be the direct addressing mode. Here the addressing field is treated as 2's complement number for this operation, and thus the effective address is a displacement relative to the address of the instruction. So let us consider a simple example, that is R is the program counter or PC. So this program counter will be playing a role of an indirect addressing mode, and then A will be the main memory. So in order to get the effective address, we have to add A and the memory of PC to get the effective address. So, and then the data, the D address, when added to the program counter, we would be getting the data. In order to understand in human language, we can assume PC, that is a program counter, contains a value called 825. So this 825 will be the indirect because it is present in PC, and the address field, it contains 24. So here the opcode would be having A, the address field, that is the 24. So when added to this PC, we would be having the PC's number at location will be 825. So when read from the memory during fetch phase, and then the PC is incremented by 1, that is 826. So the effective address will be 826 plus 24, that is 850. So when gone to the effective address is 850. So when gone to the place of 850th position, you would be having the operand. This is how an effective address is calculated. So in relative address, it is as it is similar to displacement, the addition is the same. The only thing is the in indirect addressing, in displacement, that is present in the register, and here it is present in the program counter. Rest all format, how to implement the effective address is the same. That is when the address field is added to the PC incremented program counter's memory, we would be getting an effective address. This effective address, when gone to the operand, we would be having the value. That's all. And now we jump on to the other classification of displacement, that is indexed addressing mode. So in this indexed addressing mode, here this is similar to displacement. That is, the content of index register is added to direct address part of the instruction to obtain the effective address. The here the direct field is the same, that is the address field, but the indirect will be the index register position. So the address field reference a main memory address, and the referenced register contains a positive displacement from that address. So the memory or the method of calculating the effective address is same as the base register address. It is under the classification of displacement, so the effective address calculation will be more or less the same. But here in base register addressing, we know that the indirect mode is the program counter. Here the indirect addressing will be index register. So what is this index value is that the distance between the beginning address and address of operand is index value and stored in index register. So the data array is in memory and each operand in the array is stored in memory relation relative to the base. Index addressing mode allows array implements array also. So this makes the index addressing mode more special, and it's implementing array is one of its applications too. Mm, so it can be auto indexing, post indexing, and pre indexing. So auto indexing, from the name itself we can know it can be incremented or decrement the indexed register after each reference to it. So if we have effective address A plus the memory of R, so the R will be incremented before after each reference. And post indexing is that indexing is performed after the indirection. And the pre-indexing is that indexing is performed before the indirection. So the effective address would be added after the indirection in post indexing, and the effective address, the indexing, would be added before the indirection in indexing. And the last classification of displacement is base register addressing. In base register addressing, it is similar to the indexed register, but the only difference is here the register is base register. There it is indexed register, and here it's the base register. So calculating the effective address is same as of relative and the indexed. So how to calculate the effective address is the content of base register, and that is added to the direct addressing part. As I already said, it is a version of displacement addressing mode, and here A holds the displacement, and R holds the pointer to the base address, and R may be explicit or implicit. So the address field points to the base register to obtain effective address. The content of instruction is added to the direct address part of the instruction. So as I already said, base register is similar to the indexed, except the register is called base register than the indexed. Rest all are the same. The calculating the effective address is same. Here it is added the content of the base register, that is the memory of the base register is the indirect source here, and that is added to the direct source of addressing field, such as that is A. And when added we would be getting the operand in the memory location. When gone to the effective address place, we would be having the operand, and after fetching the operand we would be performing the operation in the instruction mode format. And stack addressing mode is also called implied addressing mode. The stack is a linear array of locations referred to as last and first out queue. The stack is refers to block of location appended or deleted only at the top of the stack. That is, in a stack, let's consider a pile of coin, a pile of book. So if you need to add a book in the pile of books, if you need to add a book or remove a book, we would be removing it from the top. So that is called last in first out queue. And then the stock pointer is a register which stores the address of top of stack location. So example, add in a stack, if there is an operator and operation is add, it simply adds to operator, and the instruction pops two items from the stack and adds it. It is an example of implicit addressing mode. It does not need any register number for it, because it is already present in the instruction format. It is directly used the value is directly present and it is directly used here in the stock addressing mode. And a special case in addressing mode. There are two special cases for additional mode in addressing mode. That is auto increment mode and auto decrement mode. It is a special and very interesting addressing mode also. It is basically, this addressing mode is basically used because if in a register, the register would be having, if a register has a table of data in a memory, so then it is necessary to increment or decrement the register after every access to the table. So in order to access the next value from the memory, this auto increment or decrement is used. So if we go to a table in the register, this will automatically increment or decrement the table so that all the values can be gone through that is present in the table. So there are similar to register indirect addressing mode, except that the register is incremented or decremented after or before its value is used to access memory. So in detail, we would be seeing what is auto increment and what is auto decrement. In auto increment and auto decrement, it is more or less the same thing. That is, with some difference. In auto increment, it is incremented before, and in auto decrement, it is decremented. So that is, it's reduced. So in auto increment addressing mode, as I already said in the previous slide, it is similar to the register indirect mode. That is, in register indirect mode, the register would be containing the address of the operand rather than the operand itself. So the same way it would be having the same feature, but the register is incremented after its value is loaded at another location like the accumulator. So the effective address of the operand is the content of a register in the instruction. So after accessing the operand, the content of this register is automatically incremented to point to the next item in the list. By this way, if the register is having a table, this would automatically increment, and the next item in the list will be same. So the content in register R will be accessed, and then it will be incremented to point the next item in the list. So for example, if the effective address is 400 and the operand is in AC is 7, that is an accumulator 7. So after loading R1, it is incremented and it becomes 401. So now the item present in 401 is seen. So then again it would be incremented and the position 402 will be seen. By this way, it will go to the end of the item in the list. So auto decrement mode. In auto decrement addressing mode, here the reverse of auto increment is done. There it is incremented, here it is decremented. That is, for example, in same case, if we take 400, it is decremented and it goes to the previous item list in order to know, in order to finish the list of items. So the effective address of operand is the content of the register in the instruction, and after accessing the operand, contents of this register is automatically decremented to point to the next item in the register, in the list. These both are called special because if in as I already said, in a register there would be huge items in the list. So in order to go throughout the list, this auto increment and auto decrement modes are used. Now, we jump into the applications of every addressing modes that we have seen. Each and every addressing mode has different roles to be played, and it becomes more special due to its applications. These applications may be due to its features in it. That is, in immediate addressing mode, as I have already said, in the immediate addressing mode, it stores constant value directly in the instruction format. So the application is to initialize registers to a constant value. And in direct addressing mode and in registered direct addressing mode, its special is that in direct addressing mode it implements variables. So the application is to access static data and to implement variable. So in direct addressing mode and in registered indirect addressing mode, both are similar to each other. So its implement is that its specialty is that it implements pointers. The, that is because the pointers are memory location that stores the address of another variable, and it also used to implement to pass array as parameter, because array name is the base address and pointer is needed to address the point the address. And in relative addressing mode, um, the in relative addressing mode, I have already discussed that it is used to perform in program, and it is used in program control instruction. So for program relocation at runtime, that is for position indirect if for position independent code, and to change the normal sequence of execution of instruction for each branch type instructions, since it is directly updated counter. And in index addressing mode, it allows the implementation of array or array addressing, or and for record implementation. And in a base register addressing mode, it helps in relocation of program in memory even at the runtime. And for handling recursive procedures, as this is present in the effective address is present in the register, the register would be having many space, and the programs are present in the register, so it can easily handle the recursive procedures also. And the last one, the special modes, is auto increment addressing mode and auto decrement addressing mode. As I've already said that in auto increasing and decreasing, it is special because if there's a register, the register would be having items of list of items. So the list of items, in order to go to the next one or the previous one, it is auto increment and decremented. So thus from this we can know that it is used for implementing loops, or for stepping through arrays in a loop, and it is also for implementing a stack as push and pop in a stack. So from this, I'm ending the session for addressing modes and its types, its applications, and its benefits.